Hi everyone, in this video we're going to continue working with the double angle formulas. So this first problem tells us that we're working with arc length theta, which ends in quadrant 4, and we know that sine theta is equal to -2/5. So we have a point in quadrant 4 whose y-coordinate is -2/5. Think about that, not quite half. Okay, well that maybe looks a little bit low, but it'll give us the idea. So theta ends right here. We don't know how big theta is. Theta could be all the way around the circle. It could be this little negative angle. It could be all the way around almost 2 times, but we do know that it ends right there in quadrant 4. And we would like to find the exact value of sine of 2 theta and cosine of 2 theta. So this is another one where we should straight away head back to our formulas. There's the double angle formula for sine. So if we know that sine of 2 theta is equal to 2 sine theta cosine theta, and we know the value of sine theta is -2/5, we're really just looking for the value of cosine theta. Just as a comment on this one, please do write out what you're using formula-wise, because sometimes I can't really tell what you were doing if you just throw in numbers and give me an answer. And if you've made a small arithmetic error, that's much less of a big deal to me than if you actually didn't use the formula correctly. Okay, so cosine of theta, so I need the x value of this point. Given the y value, to find the x value, you use a Pythagorean theorem. So I'd say x squared plus y squared. Y is -2/5, so 4/25 is its square, is 1, which means x squared is 21/25, and x is plus or minus √21/5. Because we know we're in quadrant 4, it's safe to pick that positive x value. So cosine is going to be √21/5. And if we multiply through, you can put that 2/1, we get 2 times -2 times √21, which is a -4 √21 on the top. And on the bottom, we get 5 times 5, 1 times 5 times 5, which is 25. So if we go 2 times theta, we should land somewhere in here, and our y-coordinate will be -4 √21/25. To find cosine of 2 theta, we now know our x and our y values. So if you look at the cosine formulas and you're trying to take your pick of those, it doesn't really matter. So let's go ahead and use the first one just to play around with different formulas, different versions of the formula. So the first one says cosine of 2 theta is the same as cosine squared theta. So cosine of theta was our √21/5. So cosine theta squared. That's what that really means. Minus sine theta squared. Sine theta was our -2/5, and then we square it, which gives us 21/25 minus a 4/25, which is a 17/25. And that is the x-coordinate of our point. Okay, let's look at number 4. So now we have an arc length theta that lands in quadrant 4, and we're given the value of cotangent. Okay, so on the unit circle, we're in quadrant 4. If cotangent theta is equal to 4, that means tangent theta is equal to, if cotangent theta is equal to 1/4, that means tangent theta is equal to 4. Getting ahead of myself. So I'm picturing a slope of 4. Oh my goodness, I definitely lied to you. Let's say we're in quadrant 3. I'm going to say I was cutting and pasting. Okay, so if your slope is 4 and you're in quadrant 3, not possible to be in quadrant 4, can you find the value of cosine theta, sine 2 theta, and cosine 2 theta? Okay, So this is just asking, so this is the end of arc length theta. This is just asking us for our x coordinate. And what we know is that our y is 4 times our x. So we can go to our Pythagorean theorem, x squared plus y squared. Since this is our y, we're going to get 16x squared is equal to y squared is 1, which means that 17x squared would equal 1, x squared would equal 1/17, and x would equal plus or minus 1 over the square root of 17. Okay, so let's see, we decided we were in quadrant 3, so let's choose the negative x value. So this is our first answer. We know that tangent theta is equal to 4. We also know that cosine of theta is equal to negative 1 over root 17. Okay, so there's the first one. Check. The second one, sine of 2 theta. Sine of 2 theta is equal to 2 sine theta cosine theta. That's our formula, so we get that for free from our note card. We just figured out that cosine theta is negative 1 over root 17. So we've got part of this, negative 1 over root 17. We need to find our y value. So this is actually not too bad. We just need to go back to the equation for the line. Y is always 4 times x. So if our x is negative 1 over root 17, our y is negative 4 over root 17. Just multiply the x value by 4. And when we simplify, we get 2 times negative 4 times negative 1, which is positive 8, over root 17 times root 17, which is just 17. So that is the y coordinate of the point that has arc length 2 times theta. So what would that do? Put us somewhere around here. Okay, last one, cosine of 2 theta. And again, we know our x and our y, so let's just choose a formula. Here, let me sneak them in the bottom so you can see. Here's our choices. We've used number 1 in the previous problem, so let's go ahead and use number 3. Number 3 says cosine 2 theta is 2 times cosine squared theta minus 1. So again, anytime you know your x and your y, you get your pick of the formulas. If you only know x, you'd want to use the bottom one. If you only know y, you'd want to use the middle one. You could still use any of them, but that'll be the least work. And again, this cosine with the square on it means the whole thing is squared. So we need to take the cosine theta, which is negative 1 over root 17, and we need to square it, which will give me 2 times 1 over 17 minus 1, which is 2/17 minus 17/17. So negative 15/17. So now we said we were going to be somewhere over here. That's our x coordinate. So x coordinate negative 15/17, y coordinate 8/17. All right, thanks for watching.